Number 14 is asking us to find the graph for r equals 2 plus 2 sine theta. So again, same process as before. I'm going to make my theta, I'm going to make my r chart, and I'm going to try to find the zeros associated with it. So if I plug in r equals 0, I end up getting sine of theta is equal to -1. So I need to find the values where sine is -1. Well, sine is -1 at one value as far as I know, and that's 3 pi over 2. So that would be when it's right here, the bottom of a unit circle. So that's the only 0 in this case. So I'm going to go ahead and I'm going to denote that down here, that 3 pi over 2 will cause this graph to go to 0. We'll keep that in mind. But for now, I'm just going to repopulate the graph with a bunch of other values around it. So I'll plug in, again, 0, pi over 2, we'll plug in pi, we'll plug in the 3 pi over 2 that we already have, and we'll come right back around to 2 pi in this case. And again, sometimes you might need more points if you're unsure of the graph. For instance, if you end up getting a shape that doesn't match anything, you might want to try repopulating it with points. But I've found that usually just doing 5 points gets the general shape of the graph just fine. It kind of depends on the complexity of the shape. If you have one with a lot of petals, you might want to add more points than this. But for now, we'll go ahead and see what we get. So if I plug in 0, I end up getting a radius of 2. If I plug in pi over 2, I end up getting a radius of 4. If I plug in pi, I end up getting a radius of 2. 3 pi over 2 we already knew was 0. And 2 pi will get us right back to the solution 2. Because 0 and 2 pi should always have the same solution in this case. So again, I'm going to plot it on a theta and r chart. 0 and 2 is my first point, so that's out here. Pi over 2 and 4, so I'm going to go really far out here. I'm going to end up right about there. And again, I'm going to connect these lines, so I'm going to move this way. And again, I'm not very good at drawing curves, but I'm going to try my best here. At pi, I end up coming back to a value of 2. So this should be about evenly spaced, but I'm sure it's not going to be. Okay, 3 pi over 2, we come back to 0. Now, we end up with kind of a weird thing here. We end up with a term that looks like it might curve in, but in reality, if we follow our plot, it should curve back out like this. So the question is, how can we be sure? Again, let's plug in a point in between and let's see what it's actually doing. So what I'm going to do is I'm going to move this point down. I'm going to move 2 pi down, and we already knew that was 2. And I'm going to plug in a point between 3 pi over 2 and 2 pi. Let's plug in 7 pi over 4. 7 pi over 4 lies right about here. So that lies pretty dead smack in the middle of the 4th quadrant. So 7 pi over 4. So when I go ahead and I plug that in, sine should be negative in the 4th quadrant, so I end up getting a radius value of 2 minus 2 times square root of 2 over 2. So this ends up being 2 minus root 2 in this case. So what does that tell me? 2 minus root 2 is going to be like 0.6 or something like that. So it's going to be a relatively small radius. So that tells me that at 7 pi over 4, which is somewhere around this angle, I should have a value in the 4th quadrant. So it should be a positive radius. And if I extend out my point, I end up right about there. So in fact, this graph is correct. It does match up with my values. So again, just to be sure, I plugged in an intermediary point just to make sure that my graph wasn't going to do something weird like curve around inside or anything like that. So in fact, this graph is correct. And the only graph that this matches on the page is answer C. So I'm going to go ahead and write a C.
The Teaching Center, UF's Learning Resource Center.